All right, so we know, or we should know, just from the binomial theorem lesson, that anything raised to the 0 power equals 1. So here's just a few examples. 12 to the 0 equals 1. 5z to the 0 equals 1. 5x divided by y to the 0, that also equals 1. So therefore, in general, we can assume that anything, a representing anything here, raised to the 0 power equals 1. As long as a doesn't equal 0, because 0 to the 0 power actually does not equal 1. Now this is what we're going to copy here is all properties of exponents. This is one property. And the property is a to the 0 power, so anything to the 0 power equals 1 is one of the properties. Now this, I want you to kind of try to discover the property instead of just writing it down and saying, oh, this is what it is. So we're going to look, and I'm going to simplify each of these examples, and then you're going to go ahead and copy them down. That way you have the examples, and then you'll also have the property here. So this 7a to the second times negative 2a to the fifth is, again, we already kind of have this practice a little bit with binomial theorem, but not necessarily with like variables. So 7 times negative 2 is negative 14. And then a squared times a to the fifth is a to the seventh. B to the third times b to the fourth is b to the seventh. And 3c to the sixth times c to the negative second is 3c to the fourth. So looking there, I want you to look and try to discover, pause the video if you need to, what's happening? How am I getting from this expression to those answers? So again, pause the video, think about it, try to figure it out, because I'm going to show you right now. But notice how when you multiply like variables, so a squared times a to the fifth, those are like variables. They're not like terms, because the variables aren't raised to the same power, but they are like variables. They're both a's. But when you multiply the like variables, the exponents are what? And that question mark is added. 3 plus 4 is 7. 2 plus 5 is 7. 6 plus negative 2 is 4. So in general, if I have a to the m power times a to the nth power, it equals a to the m plus n power. Again, you just add your exponents. So that's another property of exponents. When you multiply like variables, you add their exponents. Let's discover these rules. We have negative 2x to the first time, or and y to the second. All of that group is raised to the third power, and that equals negative 8x to the third, y to the sixth. X squared, y to the fifth, that group is raised to the power of 4, and that equals x to the 8th, y to the 20th. Then we have negative 3x, y to the 4th, that group is raised to a positive 2 power. And that is how that simplifies. Again, pause the video, think about it, and try to figure out how did Mrs. McGuire get from here to there. And here's your answer. When you raise a group of numbers or variables to a power, that power goes to every number or variable in the group. So a times b to the nth is actually a to the nth times b to the nth. So that's your now third property of exponent that we discovered. Okay, so let's go here. Again, we're going to discover this. 4x to the third squared, b to the fourth to the seventh, 4x to the third, that group, when we square it, equals 16x to the sixth. B to the fourth to the seventh power is b to the 28th, and b squared and c cubed, that group raised to the fifth power is b to the 10th and c to the 15th. Pause the video, think about it, and try to figure out the property, because here it is. When you raise an exponent to a variable with it that has an exponent already, you just do what with the two exponents? Look up here. What do I do to 3 and 2 to get 6? What do I do to 4 and 7 to get 28? What do I do to 2 and 5 to get 10? Or to 3 and 5 and get 15? we multiply the two exponents. So in general, a to the m power, all raised to the nth power, is a to the m times the nth power. Now this doesn't mean we disregard what we did in the previous property, which is where this exponent goes to both terms. It's still going to go to both terms. 4 squared gives us 16, and x cubed squared is going to give us x to the 6, because 3 times 2 is 6. Okay, so all properties apply. It's not just some of them. All properties apply at every case. It just depends on what you're given. Okay, let's look at another property here. When we have m squared times 2m to the negative third, that equals 2m to the negative first, but we have to write that as 2 over m. This is simplified. 3z to the fourth times negative 4z to the negative sixth is negative 12z to the negative second, which is negative 12 over z to the second. And then 2b squared, all to the negative third power, is 1 over 2b squared to the third, which is 1 over 8b to the sixth. So this one might be hard to see, but pause it and try to figure it out. And then, once you think you've figured it out, in general, to make exponents positive, what does it look like we have to do? Every time we have a negative exponent, what do we do to make it positive? We move it to the denominator. We make a fraction, put a 1 over top of it. Or in this case, a 2 over top of it. Because it's so a to the negative nth is equal 1 over a to the positive nth. So anytime you have a negative exponent, you move it. Now here's a trick, and you'll need this for the problems that we're going to do in class. If in the denominator it's negative already, you can just move it to the numerator and that makes it positive, or vice versa. If it's negative in the numerator, you can just move it to the denominator and that makes it positive. So just moving it wherever it's at will make it positive. Let's check out another rule. Here, 2x to the fourth, y to the negative fourth, z to the negative third, all divided by 3x squared, y to the negative third, z to the fourth. Now what I did is I moved everything to the numerator here. So I did, I got that. I'm sorry, I forgot. I'm going to let you try to figure out what the rule is. But anyway, there's 2x squared over 3y z to the 7th. b to the 8th divided by b to the 3rd simplifies to b to the 5th. And 2h to the 3rd, j to the negative 3rd, k to the 4th over 3j to the k simplifies to 2h to the 3rd, k to the 3rd, all over 3j to the 4th. So again, pause the video and try to find the rule of what I did here, and you should find this, that when you divide the same variables, you blank the exponents, you subtract them. So in general, a to the mth divided by a to the nth is equal to a to the m minus n. So what I did here is actually I did what the property says, is subtract. So x to the fourth and x squared, that gave me the x squared. But then I said y to the negative fourth and y to the negative third. Well, if I subtract those, negative 4 minus negative 3 is y to the negative first. Because that's negative, move it to the denominator, make it positive. Same for that, move it to the denominator, make it positive. Now, what I would actually probably do in the problems is I would just say, okay, that's negative. I would just make them all positive right away. So I would change this to 2x to the fourth, y to the third, over 3x squared, y to the fourth, z to the third, and z to the fourth. See how all I did was all my negatives I moved to, if it was in the numerator, I moved to the denominator. If it was in the denominator, I moved to the numerator. And now everything's positive, so now it's just a matter of combining, using the other property of just adding our exponents. So the numerator, I guess would stay the same, and then here this would go to z to the 7th, but then we have to incorporate, well what do we do? Since the 7 is down here, I would just subtract 3 from the 7, and giving us, y. I would just subtract the 3 from the 4 and give us 1. and then the 4 minus the 2. So it doesn't matter which one you subtract. Like, you don't always have to take the numerator minus the denominator. You could do denominator minus the numerator. But as you practice this in class and get better with it a little bit, that might make a little more sense. So moving on to this one, again, discover the rules. 2/3 to the third is 8/27. X squared over y to the third, all raised to the third power, is x to the 6th, y to the 9th. And 3x squared divided by 2 squared is 9x to the 4th over 4. So, pause the video, discover the rule, and you should find this. When you raise a fraction to a power, the power goes to both the numerator and the denominator. And again, we're still using the other properties we've learned. So 2 cubed is 8, 3 cubed is 27. X squared cubed, now this is where we're taking an exponent and raising it to another exponent, so we multiply. 2 times 3 is 6. And y cubed would be 3 times 3 is 9, so that's why it's y to the 9th. And this 3x squared, again, there's multiple, so I take that squared to both the number and the variable here. So 3 squared is 9, and x squared, again, we multiply that exponent is there, so it's going to be x to the 4th, and then 2 squared is just 4. So in general, a divided by b to the n is equal to a to the n divided by b to the n. So those are all 7 properties that you're going to use and have to know for what we're going to do in class here. So if you have any questions, don't hesitate to ask in class.